Over the past decade, Flygt have supplied several thousand submersible agitators for mixing drilling fluids in offshore applications. The oil and gas industry is truly global, and we're global too. We are represented in more than 130 countries around the world, which ensures we are always close to our customers. Operational reliability and effective mixing are the two most important criteria when working with MAD in the offshore industry. To fully understand our customers' needs, we invest time and resources in both full-scale and laboratory tests. The full-scale tests provide us with important information on how our equipment operates in a working environment. Here are pictures taken from such a test in Stavanger, Norway, within a MAD production facility. The purpose of this test was to monitor temperature, vibration levels, thrust performance, flow in the tank and power consumption for different mud conditions. This is important since these applications are complex due to the fact that MAD properties vary considerably depending upon the geological conditions at the drilling site. The agitator is equipped with a series of sensors: temperature, vibration, thrust and flow. Outside the tank, we also measure the power consumption. However, all kinds of testing begin in our laboratory. In our laboratory, we have all the necessary equipment to measure important drilling MAD characteristics, including specific gravity, yield stress, and viscosity. Using scale models, we can perform a variety of tests in order to enhance our understanding in this area. Mixing is really about creating a motion or turbulence in the tank. This motion is often referred to as the bulk flow and is created by the thrust of an agitator. The amount of thrust needed to ensure good mixing is dependent on several parameters, including tank geometry, positioning of the agitator, and the type of liquid being mixed. The efficiency of an agitator is the relationship between the thrust produced and the power consumed. A more efficient agitator will have a higher ratio between the delivered thrust and the power consumed. The efficiency of an agitator is dependent on both the motor efficiency and the hydraulic efficiency of the propeller. To visualize this in another way, we have constructed a test rig in our laboratory. What we have here is simply an articulated swing. The swing is fixed to an overhead crane above the test tank. At the lower end of the swing, two agitators are mounted. You will note that they are working in opposite directions. The agitator having the larger thrust will win this battle, deflecting the swing over to the opposite side. The agitators are connected to power meters, so we can check their power consumption while they are running. Now, a Flygt agitator and an agitator from a competitor are mounted on the lower end of the swing. At a first glance, they look quite similar. As we turn both the agitators on, we can note that they produce more or less the same thrust. But when we check their power consumption, there's a substantial difference. So even if the two agitators are about equal in capacity, their power consumption rates are very different. Comparing the thrust produced and the power consumed for each agitator in this laboratory test, we see that the efficiency is 40% higher for the Flygt agitator. However, MAD conditions will also affect the mixer performance, and that's why we also wanted to make a comparison in real MAD conditions. So let's go back to our field test in Stavanger, Norway. In this performance test, we will compare a Flygt agitator with a competitor agitator of the same brand, as in the swing test. Both agitators are the same size in terms of rated power. We will monitor the power consumption and thrust produced for both agitators. The tank, which is 4 meters, 13 feet in diameter, is filled with drilling mud up to a depth of 6 meters, 20 feet. The first test is performed with the Flygt agitator. As we can see, the agitator is creating a movement in the entire tank. Now we have changed to the competitor mixer, and as we can see, there's no visible movement whatsoever. The Flygt agitator produced a thrust of 2,200 newtons using 7 kilowatts, giving us a thrust power ratio of 314 newtons per kilowatt. This should be compared with the competitor agitator, which produced a thrust of 1,900 newtons using 9.2 kilowatts, resulting in a thrust power ratio of 207 newtons per kilowatt. The result is that the Flygt mixer has a 52% higher efficiency than the competitor in this application. Our tests show that a Flygt agitator has between 40 to 52% higher efficiency than the competitor. This can also be translated into the simple fact that you will need a much bigger agitator from a competitor to achieve the same mixing results in your drilling mad tanks. The next time you compare a Flygt agitator with one of our competitors, it is important to look at thrust performance and efficiency, and not just the size of the motor. Otherwise, it will not give you a true picture about how well the equipment mixes the mad. What you see is not always what you get. Flygt, unmatched market leader of submersible agitators in the offshore industry. Our mixers have proven better performance than competitors in the market. Our tests show a 40 to 52% higher efficiency than our submersible competitors. Flygt have developed powerful engineering tools, providing our clients with the best overall solutions for their specific needs. With a global sales and service organisation, we're always close to our customers in the oil and gas industry. We're Flygt, we're global.